Welcome back to Make It Mental, everybody. So this is what I did for the first step. As you can see by this little piece right here, it's a little bit oversized, so now I got to finalize the cut. I've marked it with a black Sharpie where it should approximately go. Same with this one. Right, but I'm going to chuck it back into my drill because I know this edge here is flat and I know that edge here is flat because I cut a piece off of each end of this. All I did was flip it around 180 degrees, re-chuck it in my drill, ran the drill in reverse, then use a cutoff wheel and cut it big intentionally because more than likely something this long is going to vibrate a little bit and you're not going to get a very accurate cut. But now that it's smaller, it'll spin more true, and then I cut it again. Ideally, you want your sleeve to be flush with the top of this piece right here. So that's going to be step number one. Cut your sleeve that you're going to put on here and make it flush so it doesn't stick out past the top of there. Come on. Alright, as you can see there, it's really close, but it's not quite there yet. You look down inside there, you can see the little ring of this hex part right there. And I marked it with a Sharpie, just visualizing it where I think I should make my next cut. And I'm just going to try and take the thickness of this blade off because it's going to wobble a little bit. Your hand is not going to be perfect. If you got high-speed machinery, then by all means have at it. But I don't have but my hand tools basically. And as long as I chuck this into a drill, hold my hand steady, I should be able to get pretty close. And while it's chucked into a drill, I'm just going to go ahead and take a Phillips screwdriver and deburr the inside of it because the metal will fold over a little bit from the outside to the inside as you're cutting it, depending on how you held your rotary tool. You could probably do this with a hacksaw. And here is a little thin piece that I cut off. That little thin piece right there. Alright, we are only a fraction bit bigger than the original part. So for now, my next step is I'm going to clean off the two burr marks that you see there from the wear from the brass. Where is my pointer? There it is. I'm going to clean and polish this area up, and I'm going to try and clean up the inside of this as best as possible. And then I'm going to slide it down over here, then probably use another tool, maybe something like that to get it flush. It has to be flush, right? It has to be flush because we don't want this thing rocking one way or the other. We don't want it rocking. Even a little bit translates to a lot further down the road, right? It's like aiming a weapon. Right? You might only be shaking a little tiny bit, but the further you go down range, it decreases your accuracy a lot, right? So a little bit here, a mile down the road, could end you up 700 yards off target, right? Depending on how far you're shooting off. But so very important to get everything as accurate as possible. We want this to be as flush as possible so everything flows, rotates as smooth as possible. We don't want any binding, right? And then the next hardest part will be to drill out these holes. But first, I'll finish this one before I do the other one. So this closest hex-shaped piece, that's the shiniest, right there. You can see I cleaned it up. I just put this little small part in my drill, leaving enough to stick out. Then I used a wire wheel on my rotary tool, along with just a little bit of this compound. If you got a rotary tool, then you probably have some of this compound. And I just very, very lightly, as I spun the drill in the opposite direction as the rotary tool, I just very gently just kind of polish the surface. I don't know what I can do to the inside of this surface. It is stainless steel. There shouldn't be too much going on in there. I mean, I can't see very much there, but Once this is final sanded to size to meet this, then I'll lubricate it, and then I'll mic this out with my calipers and then drill the holes in the brass. Again, there's a comparison between what, and it looked worse than what it is. Actually, this piece here is cleaned up. Before it was full of crud, sand, and all kinds of crap. I mean, it's no wonder that the brass failed. So hopefully this makes it better than what it was in a factory original condition. So there's a look at the sleeve sitting on top there. And we're very, very close. Now I'm just going to take the sanding drum while it's still on there, and I'm just going to very lightly, because in my case I'm using stainless steel, very, very lightly. Stainless steel does not like to do anything forced, right? You have to be very slow, very patient. I'm just going to slowly grind it down some more, and try and be careful not to touch the aluminum on the inside, right? Try not to be careful, or try to be careful not to touch this part right here. Get it as close as possible. If you have to, use a hand file to finish it, right? I've decided to switch over to a stone in order to get one piece closer to the next piece. The sanding drum I think is a little bit too rough. I think the stone will do a better job at creating a finer surface that's going to be much more accurate. Now you can see how accurate we are. We're not quite there yet, but it is providing a nicer, flatter surface, right? Just taking your time, and I'm chucking it into a drill to keep the drill rotating around, as I'm also applying very, very light pressure. There's no hurry, right? You can go out and buy yourself another part, or you can try and make a better part than what came from the factory, right? So there's no hurry on this. I mean, I can still finish this long before I even got a brand new part in the mail. So there is a look so far, and I think I'm just going to call it a stop on this particular video. It's already running longer than I would have liked it to run, but I think you guys get the point of what's going on and what to do to fix it, and I'll show you when it's all finished.